In this lesson, we're going to convert the World Factory class to read all of its data from an XML file. I was originally hoping to get all of the factories in this lesson, but because of the images and pulling those out in separate files, we've got several changes we need to make in order to make the locations completely data-driven. So this is a kind of big lesson on its own. I think next we'll do the monsters, which has got a few special things we'll need to do there. And then I think one more lesson after that to cover the quests and the recipes, everything else. We'll start by opening up the solution, and in the engine project, in the game data folder, create a locations.xml file, and remember to right-click on it, go to the properties, set the build action to content and the copy to output directory to copy always. And let's take a look at the locations XML file. It's pretty similar to the game items, but there are a couple of different things. We start out with our top level node is locations, and then in between the starting tag and the ending tag on line 45, we're going to have all of our location child nodes. But in the locations, I also have an attribute up here for the root image path. Since all of our image files are going to be in the same directory for the locations, we could either put this /images/locations in the image name for each location, but I decided to just put it in one place at the root at the top level, and we'll get it here, and we'll just add this to all of the image name attributes for each location. And if we look at our first location node, we have the attribute for the X coordinate, for the Y coordinate, for the location name, and for the image file name. On line 4, I've got a child node of description. So we've got our starting description, our opening tag, and then we've got our closing tag at the end of line 4. And in between there, we have the location's description. This does not need to be a child node of location. I could have made it an attribute just like the other values, but because it's long, I don't want line 3 to be extremely long with the description text, so I made it a child node on its own. Just a personal preference. And you'll probably also notice this less than, exclamation point, square bracket, CData square bracket at the beginning of the description text. And then we've got the close bracket, greater than sign at the end of the description text. This is a special delimiter that you might want to use whenever your value, your text value for a node, could contain something that looks like XML values. So for instance, I'll just pull this out here temporarily. If I wanted to have the description include a less than sign, then the XML parser is going to think, oh, we've got a closing tag here somewhere. This is the start of the closing tag for the description. But then if this was, less than equals 45, and then some text, the XML parser wouldn't understand this. It would think, I've got some XML here, but this isn't a closing tag or an opening tag or something I understand. So the CData just says whatever is in here, if it happens to be something that the XML parser thinks is some node information, it's not. It's just plain text. It's character data. So treat this CData and the closing brackets kind of like you would treat the quotes around the attribute values. They're just delimiters to say, this is where some value starts and this is where some value ends. And if it has a special XML value in there, ignore it. Just treat it as regular text. We probably really don't need this since we're controlling the value of the description text. But this is the kind of thing, if you forget to do it, and then you, for some reason, have some special character in the middle of your description, it's going to break your program. So this just protects us for the future. Some other child nodes for the location. We've got our monsters with the monster information, the ID of the monster and the percentage of the chance that this monster occurs at this location. For the farmer's house, On line 11, we have a trader node because there's a trader here at this location, and we have the trader's name so that we can get that from the trader factory eventually. The herbalist hut location, on lines 34 to 36, we have some quests, and we have a quests node that has child nodes of quest. In this case, there's only one with the quest ID, and this is going to be the source of all of our data for the locations. Next, we're going to go into the world class. The add location function on line 9 through 12, this used to be a function that took in some values. It took in the x coordinate, the y coordinate, the location name and description, and I'll just show the previous code. So here on the left, our add location took x coordinate, y coordinate, name, description, and image name, and then it constructed a location object with those parameter values. I'm going to change it so that it just takes a completely populated location object now, because we're going to build the full location object inside our World Factory class from the XML data. And you might have noticed in the old code for the image file name, we had this engine component because the image was a resource for the application. It was kind of built in and compiled into the application. We're going to do this a little differently because now it's not going to be compiled into the application. It's just an external file sitting somewhere out on the directory, and we're going to have to read that in from the disk instead of finding it as a resource inside the executable. And speaking of which, let's take a look at the World Factory class now. It's very similar to the Item Factory class. We have our constant file name, GameDataLocations.xml. We have our static create world function. It instantiates a world, checks to see if the data file exists. If it does, it creates an XML document and loads that document object with our XML file data. Then we start out by reading the root image path. So we're going to select a single node from the top, locations, the plural one, and look for the attribute root image path. And that's going to give us this root image path value, the directory where all of our image files will be located. Then I have this function load locations from nodes. We pass in the world object because that's where we're going to populate the locations into. We pass in the root image path so we can include this value with all of our image files when we build the location object. And then we pass in select nodes locations/location. So that will look in our XML file, the document, and get all the location nodes. Inside load locations from nodes, we'll first check to see if nodes is null, and if so, return it right away. Otherwise, we'll loop through each node. We'll instantiate a new location object, and we're going to get the x coordinate value as an integer, the y coordinate value, the name of the location, the description of the location, and notice we're doing node single select node because description is a child node of this location node. Get its inner text, because here this C data for the description text is the inner text of the description node. It's not an attribute, it's the text in between the tags. And then we're going to pass in the image name. And in this case, instead of having that engine component, we're going to build it as dot root image path, and then get the location's image name attribute as a string. Then we're going to call 3 functions to add the monsters, add the quests, and add the trader at the location. We'll pass in the location object, and we'll pass in the monster nodes, the quest nodes, or the single trader node. Since there's only ever one trader, we're using select single node instead of select nodes. And all of these functions should look pretty similar. We just check to see, make sure that the XML node list is not null. Then we loop through, read the attributes, and we add, in this case, we're going to add a monster to the location. For the add quest, we're going to add a new quest to the quest available here. And for the add trader, we're going to set the trader here property to the trader factory, get trader by name. So this will instantiate complete location objects for our game into this world class. Next, since we're not using the image files as resources, we need to go over into the Solution Explorer, go into Images Locations, and select all of the location images. You can do Shift left click to select a whole block of them. Then right click, View Properties, and we need to change the action to Build Action None, Copy to Output Directory, Copy Always. So every time we build the solution, we're going to copy all of these files over into the executable or the bin directory. Just like we do with the XML files for the location and game items, now we're going to copy over all of the images. So now we have our fully populated world with all of our locations, and all of the locations have the image name as the path to the file that contains the image for the location. We need to make some changes to the UI so it can read the images from the files and then display them in the UI. And we're going to do that by going into the WPF UI project, creating a new folder that we call Custom Converters. It doesn't need to be that name, that's just what I like to put because this is going to be where we have all of our custom converters. And then create a new class in there called File to Bitmap Converter. With WPF, we do data binding to display values in the UI, but sometimes you want to do something special with the value. For instance, you might want to bind to a Boolean property, it's true or false, but on the screen you want it to say yes or no. So you could create a custom converter that would say, look at the value we're binding to, and if it's true, return a string from the converter that says yes. If it's false, return a string from the converter that says no. And then the binding is going to use this custom converter, pass the value in, get back the converted output, and that's what it's going to display in the UI. We need to do the same type of thing here for our location images, because our image property right now in the location is a file name, and we can't bind an image to a file name directly. Instead, we have to go out, read in that file name, create a bitmap image from it, and then we can bind to that bitmap image object. And that's what this converter is going to do for us. Any custom converter you create has to implement the Ivalue converter interface. And inside each class that implements Ivalue converter, you need to have two functions. You need to have a public convert function that returns an object, and you need to have a public convert back function that returns an object. Now in this case, we don't really need to use a convert back. Nothing that the player is going to do in the user interface needs to be converted back to a file, so we just have return null and we can just ignore this convert back function for now. The convert function takes a few parameters, value, target type, parameter, and a culture info. The only one we really care about is the value. This is whatever the image is binding to, the property it's binding to, this is that value, which in this case is going to be the file name string. In lines 16 through 19, we're going to try to cast that value to a string and store it in the file name variable. If that cast fails, we'll just return null. It should never fail because hopefully no one's messed with our XML files, but this is just a little safety check in here in case there ever is a problem. On lines 21 through 26, I have a little bit of a handwritten cache here, because every time we go to a location, we don't want to have to go out to disk and read in the location's image file. That could slow us down if we had a lot of locations and if the player is moving around quickly. So if we look up on lines 11 and 12, we have this private static dictionary that stores a string as the key and a bitmap image as the value. So on lines 21 through 26, we're going to say, in this locations dictionary, see if we have a key for that file name. See if we've already created a dictionary entry for this particular file name. If we haven't, then we want to add a new dictionary entry to our cache here. The key is going to be the file name, And the object, this is where we go from a file name to a bitmap image. And a bitmap image can read from a file name. If we pass it in a URI is a universal resource identifier, kind of like a universal resource locator, a URL for a website, except in this case you can use a URI for a file name. And we're going to say find the file in our app domain, current domain, base directory. This basically means where is the program running from? Where is the exe file that we created? And for us, if you remember when we looked at the XML files for the game data, that's the Super Adventure bin debug folder. Look for the file name, which we have. Remember, we've got the file name is the full path plus the actual file name. So go out and create a bitmap image from this file and add that to our dictionary. So now our locations dictionary will have an entry with the key of images, locations, home.png, and its value is going to be that PNG file converted to a bitmap object. And because locations is static, this is going to be a shared instance for every converter. So the next time we make a call to file to bitmap converter, that value is going to be in there. The first value is going to be in there. And then on line 28, we're going to say, go look in that static dictionary and return the value where the key matches the file name. So the value is going to be the bitmap image, and that's the object that gets returned from convert. And that's what the WPF UI is actually going to bind with in the image control. So that's how we get from a string of a file name to an actual image that gets displayed in the game. Now we need to go into app.xaml in the WPF project. This is where you can set up some resources that will be available to any window or any user control. It starts out with just lines 7 and 9. You'll see on yours application.resources and then the closing application.resources. So what I want to do is say, make this converter that we just created, the file to bitmap converter, make it available to any of our windows and user controls inside WPF UI. I do that by creating line 4. I have to set up an XML namespace that points to the folder. So this way, when we want to define our available resource here on line 8, this converters is this converter namespace, and the program knows to look for this file to bitmap converter inside WPF UI custom converters, our folder. And we also have to give it a key name. This is how we're going to reference it inside any of our windows and our user controls. I normally name it the same as whatever the class name is. Then we'll go into mainwindow.xaml, and on line 115, before we had source binding equals current location.image name, and it would bind directly because the image was a resource. But now we need to add this comma converter equals static resource file to bitmap converter. So that says take this value that we're binding to, run it through our file to bitmap converter, and that's a static resource, so it's going to look for it in our application resources, find the key that matches file to bitmap converter, and now it's going to know which converter to run. And that's how the UI goes from a file name to a bitmap image that can be bound to this image control. It's a long route to get to this place, but it's what we have to do, and it also introduces you to custom converters, which come in handy for a lot of other places. Now let's run the program and make sure the game still works. Okay, we're at the town square and we see our fountain location image. Move north to the herbalist hut and we see their hut. Move south a couple, there's our house image. There's the farmer's house, the farmer's field. Looks like it's loading all the images correctly, and when we revisit a location, it's still displaying it. If we put a breakpoint here in our custom converter, We can see how it's pulling it from the cache. So I'll move south. And here in our locations, our static locations dictionary, we already have these 5 locations because we visited them and created the bitmaps already. So it's just going to pull the bitmap from our little cache variable here instead of reloading it from disk. And that all works. This has been a long lesson and there's been several new parts to it. So as always, there'll be the source code on the support page and there's a link beneath the video on the YouTube video. If you have any questions, let me know. We're going to reuse a lot of this in the monster factory because our monsters have images. So we've got to use the same file to bitmap converter for that. But let me know if you have any questions and I'll get back to you as soon as possible. Thanks.